So for classwork 22, Intro to ANOVA, we're going to start out by reviewing part of classwork 20. So this first problem, plastic surgery, t-test versus ANOVA, when we get down to this second portion under B, we actually already did this. It's not actually classwork 20. It should be classwork 21. It should be classwork 20. But this is part of classwork 20, so this first part should look very familiar. It is again the plastic surgery example. Is the reason for plastic surgery related to depression scores? Or in other words, is there a difference in depression scores based on the reason for plastic surgery? So as we did last time, we could assess this using an independent samples t-test, which is what we did last time and what I would like you to again fill in here. This is good practice for you. We already did this. You can go back and look at the video. You can go back and look at your previous notes if you need to. But again, this is just to refresh. We can and we did complete this problem using an independent samples t-test. We also can, as we can see in part C, use an ANOVA to run the same test. So ANOVA, or analysis of variance. So the difference here is t-tests, we can only do a max of 2 samples to compare those, or 2 groups. With ANOVA, this works for 2 or more samples or groups. So we can use it when we only have 2, but most of the time we don't because because t-tests are just a little more straightforward to run. But we can run an ANOVA on 2 groups in the same way that we would run an independent samples t-test, and you'll see that we end up coming out with the same result. So here is our ANOVA result from JASP that I would like you to use to label the 5 steps of hypothesis testing in the space below. So for this first part, these are actually going to be, again, the same as the ones from above because we're still just talking about the same 2 groups. We've got the appearance group and the physical group, their depression scores, and our results of our ANOVA. So if this is the null, I want you to think about and write in what is the alternative. It'll be the same as previous. You should hopefully by now know what goes in step number 2, alpha level, always the same in our class. This step is going to look a little different because the F curve looks different from the T curve. So I don't need you to necessarily, don't get too hung up on this part here. What I'm looking for you to think about is there will be at some point on here, there's an F value that represents the critical F. So in this case, the critical F that we are going to use is 3.92. So I want you to imagine, again, just like with the t-test, we're using that as the cutoff point of our rejection region. But how this is different from a t-test is it's only one-tailed. So hopefully you got that from those guided notes videos. We only have one side to this. It just kind of ends on the other side. So your sample T and your p-values, these will come from up here. Sorry, I said sample T, I mean sample F. And then go ahead and go through and make your decision based off of our F and our p-values. You can either do sample F versus critical F to decide, or I recommend it's easier to compare your p-value to your alpha level. That is the one that we do most commonly and is the most straightforward. Okay, so go ahead and work through this example as we did the other one with the t-test, same kind of concept. And then once you've gone through and made your decision, there's another example that is very similar. I want you to read this description. We're looking at the effects of caffeine on a finger tapping exercise among 30 male college students. The male college students were randomly assigned. 10 of them had a cup of coffee with 0 milligrams of caffeine in it, or they were administered some sort of dose with 0 milligrams of caffeine. 10 who were randomly assigned to that group got 100 milligrams, and then another 10 were randomly assigned to receive 200 milligrams. So we have 3 different groups. One group got no caffeine, one group got 100 milligrams, and one group got 200 milligrams. Then we wait for 2 hours. And after that time, they do some sort of finger tapping exercise, and they count how many times do you tap your finger in a minute. Not exactly sure why you would want to do this. I'm sure it has some greater relevance beyond just finger tapping. But this is the idea. We have 3 groups of people. We want to know, does caffeine affect how quickly they can tap their fingers? Okay, so using that, use the information that is provided in this output. Let me help you out a little bit there. And keep in mind, this is always going to be the same. The hypothesis, going to look a little different in this case, right? Because we have not just 2 groups that we're comparing. The null hypothesis in this case is actually going to be that all of the means are the same, right? You could also write that as the mean of the 0 group is the same as the mean of the 100 group, which is equal to the mean of the 200 group. You can call them ABC. But this is essentially in ANOVA, our null hypothesis is always, no matter how many groups we have, all of the means are the same. The alternative is a little different also, because it could be that these 2 are not the same, but these 2 are. And this would still mean that they're not all the same, right? So there's lots of different combinations. It could be that this group and this group are different, but this group and this group are the same. It could be that all of them are different. But the thing is, there are different possibilities that would all make this not true. So the easiest way to really summarize all of those possibilities is to simply say, not all means the same or equal. From there, you're going to use this number to help you determine your critical F cutoff point. Remember to look back at your output to determine your sample F and your p-value, and then use those to make your decision. Then after you've gone through, I want you to do some critical thinking on this last part. So thinking about our alternative, not all the means are the same. Think about, if these 2 are equal, but this one is different, is it true that not all the means are the same? These 2 are the same, this one is different. Then if one of them is different, yeah, it is true that not all the means are the same because this one is different, not the same. So look at the rest of these ones and try to identify, is the alternative that they're not all the same true here? Is it true here? And then what are we really saying when we reject the null hypothesis? This last bottom part is for you to read and just to gain some additional information that will help as we move forward with ANOVA. And then you have a chance to practice writing up your results as well. So hopefully that helps get you started with classwork 22.